All right, so we're in your worksheet. We're flipping to moles to grams, grams to moles. Cha-cha-cha. This is what we're doing in class today. It is 10:22. All right, so the first thing we have to do is we have to look at this worksheet and figure out what they're telling us. So rather than giving you each of these problems in words where you have to write the formulas and write the equations, I've given you the equation unbalanced, so you have to balance it for me. And then I've told you the amounts of each of the substances that it's below. So for this first problem, the 0.17 moles corresponds with Na2O, and the gram question mark corresponds with Na3PO4. Do you see how they're below each other, roughly? Okay, so the first thing we have to do, always, is balance. All right, so let's balance it. If I look at the problem, I see that I have PO4 on the right, and I do not have PO4 on the left, so I cannot keep the PO4 together as a polyatomic. Do you see how it exists as a polyatomic over here, but not over here? Thumbs up if you're with me. All right, so we make our list. Na, P, O, Na, P, and O. All right, let's write down how many we have of each of these. Okay, so I'm going to have Miss Diana help me out here. How many sodiums do I have on the left? 2. How many phosphorus? 4. And how many oxygens? 1 plus 10. Perfect. Okay, and then let's have Austin help me out on the right. How many sodiums, Austin?
3.
And phosphorus?
1.
Good. And oxygen? Okay. If I glance at these numbers, I note that my sodiums do not balance. Nothing balances. Phosphorus doesn't balance, right? But I see that I have 1 phosphorus and I need 4. So I know that I'm going to have to fix that. So we're going to start by placing a 4 in front of Na3PO4. That gives me 4 phosphorus, 12 sodiums, and 16 oxygens. Okay, Kiana, how do I fix the sodiums on the left? How many do I need? 12. So what number should I place in front of that? What number times 2 equals 12? 6. Good. All right, so that gives me 12. And then 6 times 1 gives me 6 oxygens. So I have 12 sodiums, 4 phosphorus, and 16 oxygens. Balanced? Okay, good. So step 1, balance equation. Step 2, write what you are given. Write down what is given to you. What did they tell us about the problem? Ashley, what did they tell us about the problem? That we have 0.17 moles of what? Na2O. Okay, so I have to write down what I'm given. Then after I write down what I'm given, I convert into moles, if I haven't already been given moles. So Avaria, do I have to convert into moles? No, because they already gave it to me in moles, so I get to skip that step. Woohoo! Okay. So now that I'm in moles of Na2O, I can go to my balanced equation and I can convert from anything I want to. So if I look, I have Na2O, and they want me to convert it into Na3PO4. So all we need to do is a train track. Train track. And they're not interested in how much Na2O I have. They want me to tell them about what I'm going to make. So I always start by writing whatever I'm getting rid of on the bottom. Moles of Na2O, and write what I'm converting into on top. Na3PO4. I am getting rid of Na2O. I'm converting into Na3PO4. And I go to my balanced equation to tell them the ratios. All right, so McKinley, how many moles of Na2O per reaction? How many did we write? 6. Each reaction needs 6. And how many moles of Na3PO4 will we make? 4. Okay, this is the mole ratio from the balanced equation. Moles of Na2O cancel. And now I have moles of Na3PO4. And is that what they wanted? No, what do they want it in? Okay, so one more step. I don't want moles of Na3PO4, I want grams. So I know how to convert it from moles into grams. 1 mole of Na3PO4 into grams of Na3PO4. Olivia, how do I convert from moles of Na3PO4 to grams? What do I use? You got it. I add up all of their masses together, and this is the molar mass. So this conversion is the molar mass. So I grab my periodic table, I grab my calculator, and I add up 3 sodiums. 3 times 22.99 plus 30.97 plus 4 oxygens. 3 times 22.99 plus 30.97 plus 4 times 16. I get 163.94. Give me a thumbs up if that's what you got on your calculator. All right, so 163.94 grams. Moles of Na3PO4 cancels. And now I have grams. They wanted grams of Na3PO4. I've given them grams of Na3PO4. And now my conversions are done. Yes?
We don't use the mass of the balanced equation. So like the 4 in Na3PO4.
Excellent question. No, we do not. The 4 is included here in the mole ratio. When I do this conversion right here, I'm just thinking of 1 mole of Na3PO4, and this is the mass of 1. Yeah, excellent question. So these 4s and 3s and 2s only go in this mole ratio section. So we grab our calculator and we multiply, 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 divide. 0.17 times 4 times 163.94 equals, right, divided by 6 divided by 1 equals. And the last thing I ask is how many significant figures should I carry forward? Caleb, how many sig figs should I have in my answer? How many significant figures in the number they gave me? 2. So how many sig figures in my answer? 2. So I keep the 1, I keep the 8. What does the 5 do? Rounds up. So the answer is 19 grams of Na3PO4. And I box my answer. Okay. All right. Let's do another one. Copper plus oxygen makes Cu2O. Step 1, is it balanced as written? No, so we have to balance it. 1 copper on the left, 2 coppers on the right, 2 oxygens on the left, 1 oxygen on the right. So we've got to fix this oxygen problem. So let's put a 2 in front of my Cu2O. That gives me 4 coppers on the right. So what number do I place in front of the copper on the left?
4.
A 4. All right, so the first step was always balanced. We've balanced it. The second step is write down what you have been given. All right, Lillian, what did they give us in the problem? They told us information about copper. 1.5 moles of copper. I'm in moles. So I don't have to convert anything. I can go directly to the equation and convert from copper. And what do I want to convert into? Dylan, what am I converting into? Grams of oxygen. So I want to know the ratio between moles of copper and moles of oxygen. Note, if I'm changing substance, I have to have the same label. I have to be in moles to go from moles of copper to moles of oxygen. All right, from the balanced equation, Hallie, what is the mole ratio for copper and oxygen from the equation? 4 moles of copper will make 1 mole of oxygen, right? Because we pretend there's this imaginary 1 right here, right? 1 mole of oxygen. Right. Moles of copper cancels. Okay, Adon, am I done now? No, why? What do they want the label to be in the end? Grams. All right, so I'm going to convert from moles into grams. So this is the mole ratio. The conversion I'm using now is the molar mass. So 1 mole of O2 will give me some grams. All right, what is the molar mass of oxygen in grams? Good, 32.00 grams of O2, because it's 2 oxygens, so 2 times 16, 32. Note how I'm keeping these zeros for significant figures. Note how, so like make sure you're writing the numbers as given and you're not dropping zeros out so that you lose significant figures by accident. Okay, am I done converting? Thumbs up if we're done converting. Yes, Varya, you're correct. How did you know that we're done? All right, because the last label I have is grams, and that's what they asked for. All right, sweet. So grab our calculator. 1.5 times 1 times 32.00 equals divided by 4 divided by 1. Here's my calculator. 1.5 times 1 times 32 divided by 4 divided by 1. Enter. Oh, sweet. The answer is 12. How many significant figures was I supposed to have? 2. How many do I have on my calculator? 2. And the label's 12 grams of O2 and box your answer.
Wait, so how come like we didn't do the NaPO, like put that down on number 2?
Yeah.
Like what we did on the first one.
How come we didn't do...
Like on the first one we took it apart and went NaPO and then P and then O and then like their
Oh,
things.
why didn't I write it all down like this?
Yeah.
I didn't because the equation was much simpler and it didn't have a polyatomic, that PO4. See how it was all in one compound over here, but it was broken up over here? Whereas this one, I didn't do that because I could see it easier and I could balance it without. Now you absolutely can, if that helps you. Okay, should we do another one? Let's do another one. All right, I've got silver carbonate decomposing into silver oxide and CO2 gas. So what is the first thing that I do before I do anything else? Balance it. All right, 2 silvers, 1 carbon, 1 carbon, 3 oxygens, 3 oxygens. Balanced as written. Sweet. Okay, problem is balanced as written. So then, Michaela, what do I do next? Okay, I write down what I've been given so that I can convert. What did they tell me? Of silver carbonate, and they want me to convert it into moles of silver oxide, Ag2O. Okay, 45.0 grams of Ag2CO3. Austin, can I use this number as written? Can I go to the equation now and convert from Ag2CO3 into Ag2O? No, I don't. What do I need to convert it into first?
Moles.
Perfect. All right, I have to go out of grams of Ag2CO3 and 1 mole. And this is the molar mass conversion. So I need to know the mass of 2 silvers plus 1 carbon plus 3 oxygens. So I grab my calculator and I do 2 silvers, 107.87, plus 1 carbon, plus 3 oxygens, 2 silvers plus 1 carbon plus 3 oxygens, and I get a molar mass of 275.75. 275.75 grams of Ag2CO3 cancels, and I have 1 mole of Ag2CO3. Okay, and I want to convert. Yes, Dylan. This number right here? Excellent question. I'm not going to round this because it's a definition, and if I round it, I'm going to have an error in my final answer. So even though it's lots of numbers, I'm going to keep all of them. Good question. All right, so I want to convert. And I have, and this seems like a pointless step right now because the ratio is 1 mole of Ag2CO3 makes 1 mole of Ag2O, and I recognize multiplying by 1 and dividing by 1 won't change my answer, but I need to see it because I'm changing substances. So 1 mole of Ag2CO3 makes 1 mole of Ag2O. 1 mole of Ag2CO3 makes 1 mole of Ag2O. And these labels cancel. And I ask the question of, am I done with the problem? Mr. Miller, are we done? Yes. Because they wanted the answer in moles, I have converted into moles, and so now I just do the math. 45.0 times 1 times 1 equals, divided by 275.75 divided by 1. 45.0 times 1 times 1 equals, divided by 275.75 divided by 1 equals, and my calculator spits out the calculator junk. And turn and tell your table partner how many significant figures will I be keeping in my final answer. All right, Adon, how many do I keep? How many did I give you? 3. Decimal point is present. Come from the Pacific account, everybody. 3 sig figs. I need 3 sig figs. Keep the 1, keep the 6, keep the 3. What does the 1 do? Rounds off, falls off. The answer is 0.163. Label. Moles of Ag2O. Very good. And box your answer. Note how this mole value is less than 1, right? It's a tenth of a gram, or a tenth of a mole, excuse me, and that's extremely common. Your mole numbers are usually ones of moles or tenths of moles. If you're getting a number where it's like 50 moles, you probably did something wrong, or the problem gave you like 50 kilograms of a substance. But if you're going from grams of something into moles, or grams to moles, moles to grams, this should be a very small number. Okay? So be affirmed that if you're getting small numbers, you're doing it correctly. If you're getting big numbers for moles, something probably went wrong in your math. Okay, questions so far? All right. Do you feel confident continuing on your own?
But
Yes.
Like, how would you do number like 5 and 6?
So for number 5 and number 6, the only difference is now I've given you a sentence with the information. So if we read this, I have 49.5 grams of barium chloride. What's the formula for barium chloride? BaCl2. Good. We'll use how many moles of ammonium carbonate? Ammonium carbonate is NH42CO3. Okay, so I write down what I've given. 49.5 grams of BaCl2, and I want to know question mark moles of ammonium carbonate. That is the only difference. Before, I just literally gave it to you underneath each substance type, and now I'm giving you a sentence where you have to identify which mass goes with which. All right, so I've got grams, and I want you to tell me moles. Same thing with number 6. Number 6 is 2 parts. note, 2 steps, or 2 separate problems. The first part is to tell me grams of carbon dioxide. The second conversion problem I want you to do is how many liters of this. So note, carbon dioxide is a gas and water is also a gas. Okay? All right, so if you would like help, please come on up. We'll sit and work. We can make a little pod. I'd like you to work in table partners or in teams of 4. And then 1 through 6. And then the second part is the fun with stoichiometry. This is what we are going to be doing today. So, Miss B, 1022. In class, you have enough time that you shouldn't have homework, but if you're not done, it is homework. Yes? Okay? You should have enough time that you don't have homework, but if it isn't done, it will be homework. All right.